Okay, so today we're going to talk about section 5.2, which is called the characteristic equation. Okay, now what the characteristic equation is going to be used for is going to be answering the question that we ended with last time, which is finding eigenvalues. So if you remember from last time, we talked about how you can find the eigenvalues if your matrix is triangular. They're along the diagonal. What if your matrix isn't triangular? How do you find the eigenvalues? Okay, so let's do an example. Well, first of all, let's just trace how we're going to find let's trace the strategy. Okay. So lambda is an eigenvalue if a times x is equal to lambda times x for some x. So remember, this is the definition of an eigenvalue. Okay, so x is my eigenvector. Remember from last time. Okay? So in other words, a minus lambda times the identity times x equals 0 has a non-trivial solution. Okay, non-trivial solution x. Okay, so for a matrix equation ax equals 0 to have a non-trivial solution, that means that this matrix, A minus lambda times the identity, is not invertible. Okay? So remember the invertible matrix theorem. If a matrix is invertible, then that matrix times x equals 0 has only the trivial solution. So if this is going to have a non-trivial solution, that means it cannot be invertible. Okay? So if this is not invertible, that means that the determinant of a minus lambda times the identity equals 0. Okay? This equation is called the characteristic equation. Okay? So this equation is going to help us to find the eigenvalues. Okay, so let's do an example. Let's try to find the eigenvalues of this matrix. A is equal to 2, 3, 3, negative 6. Okay. So the way that I'm going to do this is by writing down the characteristic equation. Okay, so I'm going to say A minus lambda times the identity is equal to 2, 3, 3, negative 6, minus lambda times the 2 by 2 identity matrix is lambda lambda 0, 0. Like that. Okay, what is that? This is going to be 2 minus lambda 3, 3, negative 6 minus lambda. Okay, now I want to calculate the determinant of that matrix. So the determinant of A minus lambda identity equals 0. Okay, so remember that's my characteristic equation. Okay, so I just need to calculate the determinant of this matrix. Okay, so this is going to be, remember determinant of A, B, C, D is AD minus BC, right? So that's what I'm going to use here. Okay, so this is going to be 2 minus lambda times negative 6 minus lambda minus 3 times 3 is equal to 0. So that is the characteristic equation. Okay, let's clean this up a bit. So we can factor out a negative. Negative 2 minus lambda 6 plus lambda minus 9 equals 0. And then let's FOIL this out. Plus 2 lambda minus 6 lambda minus lambda squared okay, let's write this. So I have positive lambda squared because it's going to be negative, negative. This here is negative 4 lambda, and then when I distribute the negative it will be positive 4. And then I have minus 12 and minus another 9, so that's minus 21 equals 0. Okay, you see that this is a polynomial. Okay, and that's always the case. This is called the characteristic polynomial of this matrix A. Okay, so fortunately we can actually factor this. So if you look at this carefully, this factors into lambda plus 7, lambda minus 3. So this tells you that lambda equals negative 7 and positive 3. Okay, these are my eigenvalues. Okay, so this is the general procedure to find the eigenvalues of a matrix. So the eigenvalues are the solutions to the characteristic equation. Another way to say that, since what's on the left of the characteristic equation is the characteristic polynomial, you see that eigenvalues of the characteristic polynomial. Okay, remember the root of a polynomial is where the polynomial equals 0. So you can see this polynomial equals 0 at -7 and +3.